Good afternoon, this is Schweitzer. We're going to run a little smart note video on modeling atoms. This particular sample is this video is going to look at the first two um, standards, Lewis electron dots and Bohr diagrams. Of course, we'll be dabbling into some of the other stuff. All right, so what is electronic structure of an atom? Again, the main thing we're looking at here is we're creating a model with predictive power. That's all science is. I mean, all we ever do is create models trying to predict what's going to happen in the future. It's a combination of mathematics and science. So you could predict, in this case, if you have a bridge, and you got cars passing over, you got a certain wind, you got a certain span. How, is this bridge going to hold? Right now, as you can see here, we're sitting right in the middle of 2020, so we have this great pandemic, which is just, you see scientists, all they're doing is trying to predict the future, all right? And that's it. Okay, that's all we do in science. If we can't predict the future, then science means nothing. Then it becomes history, which sometimes repeats itself, but not always, okay? So all we're doing with this model of an atom is trying to build a model that can tell us what it looks like, so in the future we can try and predict how it's going to act. And that is, that's really where science becomes useful, science and mathematics. A lot of our models are mathematical, so they can then mathematically predict the future, which is great. All right, what are the models of four quantum numbers? So I'm not going to show all four here, but we'll just emphasize two of them here. First of all, we have the principal. Okay, this is symbolized with the letter N, and just simply matches the energy levels. Okay, so in our simple periodic, let's say we're talking about a Bohr model here, just showing energy levels. This is N equals 1, N equals 2, so on and so forth. All right, so these guys have numbers that actually, it says quantum number. I've given it a letter here, but the number actually refers to 1, 2, 3, 4, and so forth. All right, now we have next one would be the orbital. Orbital. So we don't typically want to give a human experience to anything here. They on AP test will not expect will not give any human alliteration to anything. So you say that an atom works this way because it's happy or sad, or that's never going to work. But here, I might call an orbital like sort of the location where electrons are likely to be. Okay, a location of the electron cloud. That's probably the best way to describe this. In chemistry, we might describe this as sort of like the house that they're living in. Of course, we would really want to avoid that. So what are they? Well, we have S, we have a P, and we have an L. Sorry, an L. We have a D, and we have an F. Okay, this thing is symbolized by the L. So a little lowercase l this is an N. Okay, so now each of these orbitals also has what's called a suborbital. Okay, or a sublevel. This guy has 1. This guy has 3. This is sometimes could be referred to a human sense of rooms in a house. 5 and 7. Now again, it's quantum number. It's orbital quantum number. Now that number we're referring to is 0, 1, 2, and 3. Okay, those are an S is a 0, P is a 1. So there's numbers that goes along with it too. This suborbital is called the magnetic quantum number. That's our next one, magnetic. And I'll just mention that the fourth one is called a spin quantum number. Okay, and we'll talk more about those later. Okay, so here we go. Like I said, we're really focusing on the Bohr diagram, which is this idea. All right, so electrons and suborbitals, you should be aware that every time this is called an Aufbau chart, by the way, Aufbau. Every time we move up an energy level, this is N, okay, this is L, that we get added another energy level. So first energy level is called the 1s. Now the s orbital has one suborbital. Okay. These subs can hold a maximum of 2 electrons. Less, just not more. So this guy can hold a total number of electrons, max, would be 2. 1s, 2. If they're located in the first energy level, it could be just like this. Boom, boom. You can sit there and you can put an E as well. This is my nucleus. All right. So the second energy level gets a 2s, 2, and it gains another one we call 2p. So every time we add an energy level, we add an additional orbital. So the p orbital has 3 suborbitals, and therefore 6 electrons maximum. Less is okay, just maximum 6. So 2p6. Total electrons, which you learn in maybe middle school, will be 2 electrons here, 8 electrons here. This number here, not so useful. Okay, so useful, so not so useful that you teach it in middle school, and there's a lot of stuff underneath that they don't tell you because that would be really confusing. Either way, I have 8 electrons, so 1, 2, 3, 4, 5, 6, 7, 8. So now we have a model here that's showing good things the model shows here is that it has energy levels. Okay, but it's not showing much else beside that. So this model starts to really fail when it starts looking at suborbitals. So it's important to know what a model can show you and what a model can't show you. Don't expect a model to show you something that it can't show. And if that's you're trying to, then you're just getting false information. So, for example, we have valence electrons. These are the outside ones right here. Okay, some models only show valence. Okay, that would be called a Lewis dot. All right, only shows that. We'll show us in a moment here. Okay. So, anyways, that being said, let's continue on here. So we got, I'm going to go too far, 3s2, 3p6, 3d2. All right, so that's 6 plus 2 is 8 plus a d. It's not 2. Let's fix the d. D has 5 suborbitals, which would be 10 electrons. So that should be a possibility of 10 electrons there. I'm not sure where the 2 came from. All right. So where do I put them on here? That's 18 total electrons. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Notice I'm adding them in twos because that's like my suborbitals right there. But again, what do we got here? Okay. So we have next energy level, fourth energy level. Let's add it right here. Okay. Fourth energy level would be 4s2, 4p6, 4d10, 4f14. So that 4 right here, let's just do this guy. Okay. There we go. That's my 4s2. Okay. So that's our basic Aufbau chart and Bohr diagram. Keep in mind that the way this thing fills, that's pretty important here. People think that this is going to fill just from outside in. That's not the case. This thing fills everything in terms of energy. Okay, so this is the lowest energy right here, and it increases in waves to this area being the highest energy. Does not necessarily fill in order. This is my lowest, these two. Then the next one, then it follows in sort of a wave. And then it goes here. So I fill my 3p6s, but then notice the 4s2 gets filled. So this 4s2 is going to get filled, okay, before some of the 3s. Let's just say this is my S, hypothetically. These are my Ds, or my Ps. Okay. But then the rest of these guys are all of my Ds. Those are my 3 Ds. So this thing is going to backfill, fill this one first, and then fill in the Ds, and then fill in the Ps. Now you notice the Lewis dot diagram only shows the valence electrons. So when you're backfilling, your valence electrons really aren't changing much. The outside is your valence electrons. So if you get those 4 2 filled in, it's not going to fill in the ends. It's not going to change the valence by backfilling. So, good information. Aufbau chart for carbon. Okay, so now how do we do this? Okay, well, first things first, um, what do I know here? I got 2 energy levels here. So the periodic table, which we'll mention in a moment here, on the next slide, is going to really tell us the whole story. I'm located right here, and the Bohr diagram doesn't really show us 2 models. You could maybe get sketchy in the second one, but really it's showing us energy levels. And that is the principal one. Oof, pencil's running away from me. Okay, principal. So I have 2 energy levels, right? N equals 1, N equals 2. The first one's got 2 electrons, and the second one has got 1, 2, and then 3, 4. 1, 2, 3, 4. Assuming the carbon is neutral. Okay. All right. I just kind of mentioned that we have this idea that might correlate to the periodic table. Now, in this one, they're asking us to use the Aufbau chart. So what I would do with this guy is I would go here, first 2 right there, and my next 2 are right here, and then of the 6, I'm going to grab just 2 of them, 2, 4, 6, in this order. And that is what I did here. This is another version of the Aufbau chart. It's upside down from what we just did, but here's the first 2, which is this guy, and then the next 2. Now this is my S electrons. It's not showing that. Notice I don't even have them together. So it's not a very good model for showing a lot of detail. And on here, I'm just using 2 of them. There's those 2. Okay. All right. Moving along here. Okay, what do we need to know about doing lots of Bohr diagrams? And I don't always want to use my Aufbau chart. I want to use the periodic table. So just the principle, like I mentioned. Okay. How many electrons do I need, and where do they go? You know, if I'm going to do one, okay, let's take, for example, I don't know, let's do lithium right here. Let's do lithium right here. Lithium. Okay. Well, first of all, you start your nucleus out. All right. How many energy levels do I have? Well, I got 1 and I got 2. Okay, so draw 2 circles around. All right. How many electrons? Well, I got 2 in my first one. 1, 2, and then I got 1 in my third. There you go. That's all of it. Now the d electrons are backfilling, so these are actually, this one right here is a 3d backfill. So it's not perfect using periodic table, but it's pretty darn close for what we'd use it for. Is there a relationship between Bohr diagram and periodic table? Absolutely. First energy level, second energy level, third energy level, fourth energy level. This thing is just showing energy levels, which the periodic table shows you. Let's try some examples. Beryllium. Find it on the periodic table. Okay. Nucleus and their common ions. Okay, so 1, 2 energy levels. 1, 2, 3, 4. Most common ion, want to lose these to expose a full inner shell for stability purposes. Beryllium plus 2. So that would be nucleus. Okay, still got 4 protons, and I've only got 2 electrons, and there they are. Nitrogen. Find it. It's got 7 nuclei. How many energy levels? 2. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. Did I screw that up one too many? There's 7. So let's back that up once, a little bit. All right, back up, please. Not too much, but that's fine. All right. 1, 2, 3, 4, 5, 6, 7. I put them together. However you want to do it. We'll learn more about this later to kind of figure out kind of how I put things, but showing just a little tendency, but this is fine. So I want to get myself a full shell. So I'm really close to filling. I need 1 here and 2 more there. So I need 3 more. So N-3 is my common ion. So I need nucleus, 7, 2 energy levels. I didn't change or lose energy like this guy. How much smaller that guy got. This one, similar size. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there we go. Next one. All right. Magnesium. Now they want Bohr diagram and the Lewis electron dot. I talked about that, but we didn't really do one. So magnesium, all right, magnesium's got 3 valence electrons. So it's got a nucleus. So sorry, 3 energy levels. 1, 2, 3. First 2 is full. I got 8 in the second one. So I'm just following my periodic table across, you know. So I'll just sketch that out quickly here. Make sure you understand. I'm just following the periodic table. All right. Whatever. That's the worst periodic table I've ever made. All right. So the first 2, and then we're going second row. All right. Here, and then we're third row right here. So this is full, and then I got 2 more putting me right here. Okay. Walking the periodic table, just filling in. All right, so sulfur. Okay, so find sulfur on the periodic table. All right, sulfur is located in the 3rd energy level, so it's like right here. So I need to fill in these 2. Okay, sulfur, these 2, this one and this one. I need these 2 S's, but that's the next energy level. I need these 6. And then these 2 here, which is the 3rd energy level, so we need another one stretching around here. And that's those 2. And then I need 1, 2, 3, I believe. Yep. 4. So 1, 2, I'm going to go with this 3, 4. Okay. And Lewis electron dots. 2 valence electrons. Magnesium. 1, 2. Sulfur. It's got 6 valence electrons. 2, 4, 6. 1, 2, 3, 4, 5, 6. And you might find out later why I'm separating those 2. But it's good the way it is. And that's the end of our video. Thank you very much.